Alrighty, are you ready for a challenge? You're gonna grow because of it. We are dividing decimals. Now the good news is, if you know long division and could solve something like this, great, you are gonna be able to do it when it's a decimal version. Not a lot changes. I'll just go ahead and tell you right now, when the only decimal is in the dividend inside the bracket, simply put a place value marker, your decimal point, right there in the answer column. What does that do? That maintains the place value in the answer up here. You have the decimal there, so you've got the ones place, tenths, and hundredths. This is going to divide into it like normal, and your decimal point keeps the answers aligned. Just to give you a hint, this one's going to have a tricky answer for you, so I'll give us some easier ones to work with for our next problem. Let's go through this simple one. Now, it's not too early to put that decimal up there. If you want to do that at the start before you even solve anything else, go for it. It helps you to remember to include that. If you don't put that decimal in, even though you have the right numbers up there, you won't have the correct answer because their place values will be different. So you could put it in right now if you want. I'm going to see if I can remember it later. Now this is like normal long division. 8 going into 3 does not fit, so you can mark it with an X or put a 0 there, whatever you're used to. Now it's 8 into 39. How many times does 8 fit into 39? And it'll fit 4 times. 8 times 4 is 32. Now I can subtract. 9 times 2 is 7. 3 minus 3 is 0. So just have that 7 there. The next step is bring down like normal. 8 fitting into 72. How many times does 8 multiply into 72? There are 9 8s in there. And what is 9 times 8? That's 72 as well. So these are going to cancel out. We have no remainder, and it's just that right there. But there's one more thing we haven't done. Oh, decimal right there. I want to make sure that we get that right. Awesome, we did it. And with adding decimals, subtracting decimals, and multiplying decimals, estimating is our friend to help us find if we put the decimal in the right spot. So let's take a look at this as a rounded number. 39.2, 39 and 2 tenths. It's close to 40. So what's 40 divided by 8? 40 divided by 8. 40 divided by 8 is 5. Let's compare our answer. Is 4 and 9 tenths, 4.9, close to 5? It's very, very close to 5. So I think we put our decimal in the right spot. But what do we do when there's a decimal in the divisor out here? That's what I want to show you next. So this can be the trickiest part of all with dividing decimals. Let's take a look. Here's the problem I have set up. 7 and 35 hundredths divided by 5 tenths, or you might say it's 7.35 divided by 0.5. Now sadly, because we have a decimal here out in the divisor, I can't just put this right above it, because that only works when I'm dividing by a whole number, such as 3 or 7 or 6, not when I have a decimal part of a number that I'm dividing by. So I'm going to show you a trick that we can use to still solve it simply, but get the correct answer. We're going to solve an easier problem that has the same result. That's a trick you use over and over in math. Solve the easier problem that has the same answer. And here is an easier problem that has the same answer. Take a look as you compare these two. What do you notice? Similar and different. Well, the decimal place of both of these were moved to the right one spot. That gave us a whole number 5. Whole number divisors are easier to work with. And gave us 73 and a half, 73 and 5 tenths right here. This has the exact same solution to this problem here. We can solve this easier one and know that it's the same here. Why did that work? Because I multiplied both of these numbers by 10. That's what you do when you move a decimal over one spot. You're either dividing or multiplying by 10 for each place value you move. And if I multiply both of my numbers by 10, I'm changing them by the same amount. It's like this. You've got a scale that you want to keep balanced. Just like that. And you've got a weight on this side and the exact same weight on the other side. The scale is balanced. This is a good way to think of an equation with our equal sign right there. This side equals that side. When I move both place values over one spot, I'm multiplying by 10. I'm affecting both sides of the scale in the same way. If I just added a large weight to this side, stack this guy right on there, this scale is not going to stay balanced. But if I affect the other side in the exact same way, the scale remains balanced. That's why I can change both of those values by the same amount. That kept the scale balanced. So let's actually solve this just to make sure we've got it. This is the similar problem, the easier one with the same result. 5 going into 7 one time, and that's 5. 7 minus 5 is 2. Bring down. How many times is 5 going to 23? 4 times. And 5 times 4 is 20. We have 3 left over, so we bring down this 5. 5 fitting into 35. How many times? It's 7. And 5 times 7 is 35. So no remainder. Nice clean number. But this is incorrect. What's incorrect about it? We forgot one thing. The decimal place in the answer. And let's do some estimating to make sure we could see why that's true. 73.5 is close to 70. So 70 divided by 5. Or how many 5s go into 70? We could solve that real fast. Very easy. It's going to be 14 times. Is our answer close to 14? Well, when the decimal is here, yes. When the decimal's not there, 147 is not even close to 14. So we bring the decimal up into the answer column, which we can do now that we have a whole number divisor. Let's do another problem that's difficult. All right, beware, we have a decimal divisor, which means if we put a decimal in the same spot over here, it's not going to be correct because we're going to be acting as if we were dividing by a whole number 4, not a 4/10. So how can we switch this up so that we are dividing by a whole number 4? We want something like that. But if we switch this, we need to switch the other number by the same amount. Here's a simple way to do it. How many times did I move the decimal over to get a whole number? 1 time. So I also move this over 1 time as well. Now I can set up my similar problem with an easier answer. This right here is going to have the same solution as my original problem, but now I can stick the decimal in my answer spot because I have a whole number divisor. Here we go. 4 fitting into 1 doesn't happen. So 4 fitting into 14 happens 3 times. And 4 times 3 is 12. All right, we subtract it and we get 2 left. I've already put my decimal in the answer spot, so I'm feeling good about that. Now I can bring this 8 down to continue the division. 4 going into 28 is 7 times. And 4 times 7 is 28. And that leaves me with no remainder. Awesome. 3 7/10. Let's check this with rounding to make sure. 14 8/10 is close to 15. So we're fitting 4 into 15. How many times does 4 fit into 15? Oh, it almost fits into 4 times if it was 16. And so it's going to be about 4. And 3 7/10 is about 4. Our decimal placement is correct. If we had the decimal there and it showed 37 or 0 and 37/100ths, we'd know that that's not correct because our estimating showed us it's about 4. All right, here's one slightly different one. What about when there's a decimal only in the divisor? There's not in the dividend as well. So here's our setup. Well, first off, where's the decimal in the dividend? It's going to be right there after that, after our ones place of 8. But because we don't have a whole number divisor, we can't put this right up there. Because long division assumes that we have a whole number that we're dividing it by. So what do? The same trick of shifting over the decimal until we have a whole number in this position. So I move it over one spot, and I get my whole number 8. What do I do right here? Where is the decimal? Well, we decided it was right there, and I move it over one spot right there, but what do I have there? Nothing. But even the word nothing is a mathematical clue. Nothing is represented by 0. So my easier problem with the same result is going to be 8 dividing into 2,480. Let's take a look at that. It's a big one, but we can do it. 8 does not go into 2, but it goes into 24. How many times? 3 times. And 8 times 3 is 24. Subtracts exactly. So we bring down the 8. Does 8 fit into 8? Yeah, one time. Exactly, with no remainder. No remainder there. 8 does not go into 0. How many times? Well, it fits in 0 times. And we do need to show 0 because 0 is a mathematical value. And we need to record a result from this column. So we did it, 310. Is our decimal in the correct place? Let's go back to our original equation and check by rounding. 248 is close to 250, and 8/10, it's kind of close to 1. So 250 divided by 1, we're going to be somewhere around 250. Let's check our answer. 310 is somewhere around 250. It's at least not really, really far off like 31,000 would be, or 0 and 3100ths would be. We've got the place value in the right spot. So there you go. Pay attention to the place value, but dividing decimals takes a little bit extra work when you have a decimal in the divisor. Shift the place values over in both the dividend and the divisor, and that way you put your numbers in the correct place value and you get the correct results. And estimating and rounding can help you make sure you did it correctly. Hey, if this video helped you, you can give it a thumbs up to help me back. I think you are ready to tackle problems like this. Great work.